Good morning all. Today we discuss the lesson matter around us part 5. In part 5 we discuss that can matter change its state or not. But before that we go for revision of part 1 to 4. In 1 to 4 we learn that matter, what is matter? Matter is nothing but which occupies some space and have some mass, and this matter exists in 3 states: solid, liquid, gases. And we already discussed some properties of solid, liquid and gases, the shape, volume, compressibility and diffusion also. Okay. For shape we discussed that solids has fixed shape, liquids don't has fixed shape, gases don't has fixed shape. And about volume, solids has fixed volume but liquids and gases don't has the fixed volume. Gas don't has the fixed volume, liquids also have fixed volume. And compressibility, we can't compress easily solids, but we can compress liquids and gases, but gases are fully compressible. From that only we making the LPG and CNG cylinders. And last property, diffusion, that also we check out one lab activity also. Okay. So, this is the revision, a review of part 1 to 4. Now, we discuss this, can matter change its state or not? Yes. Yes or no? How we know? We take a activity. If we take some coconut oil, this coconut oil is a liquid. This is in the state of liquid, but in winter season we see that this coconut oil becoming the solid. So, by cooling this coconut oil, this will become solid by cooling. And water also, if you see water, if you cool the water, it will become ice in the refrigerator. And so, the matter is changing its state. Yes? Yes, we can say that the matter change its state by cooling or heating. How? For example, ice, if you cool the water it becomes ice, but if you heat the ice it again become water. So, this is solid, this is liquid. The water is becoming liquid to solid by cooling, and the ice is becoming water, that is liquid to solid to liquid by heating. And what about camphor? Camphor, what is camphor? Camphor means in puja we uses this camphor for harati. Harati. So, in Telugu the camphor known as karpuram. See, camphor become directly solid to gas. Solid to gas. If you take some camphor and leave it in a room, it will disappear after one day. How? Because it is becoming gas, that's why it disappear. And naphthalene balls also, naphthalene balls which we keep in cloths, after some days there will be no ball in class. So, it is becoming solid to direct gas. So, see, so matter is changing its state. So, first of all, we have to know what is in this matter, how the matter is made. So, for that, all matter is made up of particles. These particles are very tiny. How much tiny? We can't see with naked eye. So, how you know how small are the particles? We can do our activity. So, what activity? First of all, we have to take a beaker. This is a beaker. In this beaker, we taking some water. After that, we adding some ink, or we can take a potassium permanganate. We can take the potassium permanganate also. Then it will change its color. If we add potassium permanganate into water, what will become? It will become pink. It will become pink in color. So, now we have to take another beaker, and now from this beaker, from this pink color water, this is the 100 ml water. From this, we taking 10 ml water. From this, we taking a 10 ml and pour into this beaker. So, we pour this pink color water, 10 ml pink color water in this beaker, and now add water, 90 ml water, that is colorless water, add in this. Now, see what is the color of this second beaker water. This is also in pink color. So, take another beaker and take 10 ml from this into this beaker, 10 ml pink color water, and add 90 ml colorless water. Again, see what is the color of this water in beaker, third beaker. So, we can see that this is also some lightish pink. This pink color becoming. So, if you add in another beaker, if you take the another beaker, this will also in pink in color, but is lighter than this beaker. So, we can do this activity to 4 or 5 beakers, but still we see the pink colored water, lightish pink colored water. So, from that we said that how much particles are tiny. So, they are very tiny. We can't see with the naked eye. So, particles are very tiny. So, matter is made up of tiny particles. Okay. So, next we know that if these particles have some space between them or not. The particles exist space between particles or not. For that, we can take another activity. Now, we are taking a beaker again. In this, pour water, 100 ml of water. So, in 100 ml of water, we are adding some salt. In this. Now, observe this 100 ml is increasing or not. But we can observe that the water, by adding salt, the volume of water is not increasing. Not increasing means where the salt is going? So, the salt is going in the spaces between the water particles. If you want to, so these are water particles. Assume that these are water particles. If we add salt in this, the salt will go in the spaces between the water particles. So, if we adding some more salt, it will go again in the salt, disappear in the water. So, we can say that there are some space between the particles. So, there is some space between the particles. So, next thing we observe that is the particles have the force of attraction between the particles, force of attraction. See, now already you observe that if this is a chalk piece, this is in the state of solid, this is the shape of in a cylindrical shape, this existing in cylindrical shape also. So, this shape is con changing. So, there are some attraction force between the particles. So, these are very tiny particles we can observe. So, there are some force of attraction between the particles. That is why it is in the shape of solid. Okay. So, in every matter, in every state, between the particles, between these two particles, there is some force of attraction. By this force of attraction only, that is, we are watching the states. Okay. So, next point we going that how diffusion takes place. We already discussed about diffusion, but now we are discussing that how diffusion takes place in the solids or liquids or gases. But solids there is no diffusion. Why? If you observe the particles from a solid, from a liquid and a gas, if you take, okay, here there is some cube, same this is a salt, okay, this is a sugar, this is one sugar. If you take lot of sugar, no, take only one pinch of sugar. In this pinch of sugar, if you observe from a magnifying glass or microscope, we can observe the particles, how the particles are arranged in one sugar cube. This is the arrangement of solids. So, see, there are large forces of attraction in solid particles. That is why they arranged in a systematic manner. But here also there are some space between these particles. But the force of attraction is larger than liquids and gases. That is why the solids can't diffuse. And if you take the liquids, if we take some water, the liquid particles will like this. So, see, there is no systematic arrangement, there are lot of space between the particles, so the force of attraction is less than the solids, less than the solid particles. So it will diffuse. But if you take the gas particles, there are large gaps between the particles, and the force of attraction also very smaller than the liquids and gases. That is why gases diffuses easily than liquids. Liquids diffuses but less than the gases. Solids can't diffuse, but solids diffuse in liquid particles. We can say that. Okay. So this is the lesson we discussed. In this part, what we discussed, we first of all discussed that change of state. First thing we discussed change of state, how the state is changing from one state to another, and second one we discussed about particles, and we discussed the space between particles and force of attraction between the particles, and how the solids, liquid and gases particles are arranged. Okay, this is the lesson. In next lesson, in next part of this lesson we will meet. Okay, so subscribe this channel, share this video to your friends.